Good day. So today's topic is models in IoT, applications in IoT, that is domain-specific IoT in agriculture. So what are the core concepts in them? Like what is precision agriculture? Precision agriculture is one form of concept that uses IoT technology to observe, measure, and respond to and intra-field variability in crops. And the paradigm shift or a traditional form uniform treatment of reference example of technology, precision agriculture, right treatment at the right place at the right time. This is a data-driven method. So the role of our computer science in this particular domain is this domain is not about agronomy or it's about applying core sensing, networking, data analytics, and automation to solve agricultural challenges. This is a main core thing. And the IoT architecture and agriculture is like what we do from the computer science for this particular thing. A typical agri IoT system can be broken down into a layered architecture, which is an excellent way to structure the lecture. So, sensing and perception layers. Our CS components are sensors and actuators. Agriculture applications, examples, sensors, soil moisture, temperature of humidity, and nutrients, lights, and actuators, water valves, fertilizer, injectors, fan controls, robotic arms for harvesting, uh, and networking and communication layer. Communication protocols are used for perspective like short range, Bluetooth, Zigbee for field clusters, long range, LP-WAN, LoRaWAN, NB-IoT for sending data over kilometers with low power. A cellular 4G, 5G for high bandwidth or task example drone or video. And And next is data processing layers. In this edge versus cloud computing range. Edge computing on device processing for immediate actions, example soil moisture less than 20% or bigger value more. And also cloud computing centralized data aggregation for historical analysis, ML model training, and long-term insights. And application and interface layer. And in this software and analysis, like dashboards visualizing fields data for farmer and mobile alerts sending and SMS or notifications, automated design decision engines, ML models that predict disease outbreaks or optimize irrigation set schedules. So practical use case and system designs are like use case one automated irrigation system. And this problem is water waste or over underwater. IoT solutions sensing soil moisture sensors placed at different depths and locations in the field. Communication data sent via LoRaWAN or to a central gateway. And processing our HDA like microcontroller at the gateway runs a simple rule if moisture less than threshold, then activate water valve and processing cloud. Like data is logged to analyze water usage trends and adjust the threshold based on weather forecast data. And applications of farmer receiving gives a weekly water usage report on their phone. And use case 2 crop health monitoring and pest management. Problem delayed detection of diseases, pests leads to crop loss. IoT solution like sensing, drones equipped with multi-spectral cameras fly over the field, communication 5G, 4G to transmit high-resolution images to the cloud, processing cloud, a pre-trained convolutional neural network CNN models analyze the images to identify early signs of fungal infection or pest infestation based on leaf color texture. Application, the system generates a heat map of the field on the dashboard, pinpointing affected areas and recommending targeted pesticide application. And key technical challenges for CSE students like power management, sensors in remote field need to be energy efficient, discussion solutions like solar power and low power protocols, LoRaWAN, And the connectivities are like ensuring reliable network coverage in the rural areas. This is key trait for LP-LAN adoption. And data standardization in this application data comes in various formats. Mention initiatives like Agro, scalability and cost, designing systems that are affordable for individual farmers and scalable for large agri businesses. Security, protecting the IoT network from cyber attacks that could disrupt farm operations. In-class activity design and IoT solutions. You can do a uh, scenario, the vineyard owner wants to prevent from frost damage to his grapes or forecast occurs of the frost occurs when temperature drops below 0 degree on a clear night. Tasks are in group of 3 to 4 students must design an IoT system to solve this. Deliverable, a brief architectural diagram and data flow explaining what sensors are needed. Answer, temperature, humidity, where would processing happen, edge or cloud. Answer, edge for immediate response. What actuator would be triggered? Answer, water sprinklers. The water freezes, releasing latent heat and protecting the buds at 0 degree centigrade. What protocol might be used for communication? Answer, LoRa or WAN for long range and low power sensor data. Further readings or like you can do or project ideas, you can do these kind of things like reading research papers on LoRa, web performance in agricultural settings, or CNN for plant disease detection. Project ideas like hardware provides Arduino or Raspberry Pi, DSGT, 2210 productivity sensors. This I can see as the other students' activities to learn this technology and another LoRa. So software tasks like program the device to read sensor data and transmit it via LoRa to a receiver. The receiver should log the data to a CSV file and trigger a high temperature alert. And learning outcomes or once you finish learning and do all these exercises and projects, like hands-on experience with the full stack of perception, networking, and software applications areas. That's it for the agriculture and domain-specific IoT. Thank you very much.